Welcome everyone to this innovation workshop powered by BHS. My name is Markus Hütter, I'm the CEO of BHS Technologies, and Natalie.
Hi everyone, my name is Natalie and I'm responsible of marketing at BHS Technologies. Today I'm going to take you through the questions and answers section later. So anytime if you have any questions or anything you want to ask or comment, just type it into the chat and we will go them through together later.
Thank you very much.
Thank you.
Okay, now I want to guide you quickly through the program. So I want to go with you through the innovation itself. So I want to show you what's behind this new innovation which we bring out, which is called the ArcView. Then we will have a live demonstration with Professor Bohr from the University of Regensburg, providing us with the insights of a cochlear implantation using this new type of technology. And at the end of the session, we will do a Q&A part, to make sure that also your questions are getting answered. We as BHS Technologies, we believe, that the devices should adapt more to the surgeon and not the other way around. We believe that the user is in the center of all our innovation, and we need to make sure that all the users can use our medical devices as easy as possible to make sure that they can focus on the essential part of their surgery, because the patient is in the focus and not the medical device itself. Today we are covering even more countries than we ever had before. Now we also are providing the RoboticScope also to the United States. So we also have our outside market from Europe, and we also provide it for Australia, which are suffering at the moment from a deep lockdown, but it's still possible now to make sure that RoboticScope and the innovation is available in these countries. What we learned, is that also many ENT friends, which we have for years, are suffering from back pain, and we need to make sure that the ergonomics is getting better. Myself, I've been watching so many surgeons, and I've observed that many had issues with back pain, with chronic back pain. We thought we need to make sure that this is also getting better cured and they are having a better upright position, because we believe if you have a good ergonomic position, if you have a good ergonomic system, you will also get a better outcome with the medical device. And due to the point that we are now in more than 14 months on the market, we need to make sure that we are providing the feedback we get from many users, and that's why we want to show you now the ArcView, which is part of the whole journey we do with the RoboticScope. What we were looking like is we wanted to make sure that, because sometimes you're reaching difficult kind of positions, and therefore we want to provide innovation to ensure that especially mastoid surgery is getting performed better, using the RoboticScope. We have seen many interesting applications with the RoboticScope, and we want to make sure that we continue with all the feedback, all from the users, to make sure we implement this into the whole system. Our device consists of software, of course, and also hardware, and to make sure that this is getting improved, we built an optical system which is ensuring the rerouting of the optical signals by 45 degrees to ensure that mastoid surgery and also tympanoplasties are getting done easier with such a system. And so there is a hardware module with the ArcView, which is our new innovation, and there's also a software part, because the software is an essential part to make sure that the robot is doing what you want him to do. The software is a major part to ensure that the focus point will stay always in the middle, and the surgeon can always have the essential part in the center of the view with the system. We also can reach an angle of approximate of 80 degrees to make sure that you can really see from flat angles into the surgical area. We are somehow limiting that to make sure that it's still a safe system but a solid view, which is many times hard to reach with conventional systems. The important application for the ArcView is for sure for ENT applications and neurosurgical applications. In the ENT area, it's very important for mastoid surgery, because we learned that there are many applications where it's essential to have a really look from a steeper angle to ensure that you have a good overview in the cochlear implantation. Now I want to introduce you Professor Bohr. Thank you, Professor Bohr, of coming to us, making sure that you can demonstrate a cochlear implantation. Professor Bohr is the head and chief in the University of Regensburg in the ENT department, and will show us today a implantation of a cochlear implant, as well as some application with a tympanoplasty.
Hi, nice to be here. Hi everybody out there, and it's wonderful to be here in this innovative place, and I'm very happy to be part of this presentation today.
Thank you very much. Professor Bohr is one of our first believers, and a big innovator in the whole field of ENT, and also is now engaged with the RoboticScope, is having a system there, and can demonstrate this, of course, in the best way directly. Okay, thank you very much. Now we will start with the preparation.
Good.
Used for teaching purposes, because he can have a real view onto the surgical area without doing the surgery himself.
Okay, so now here you can see one of the biggest advantages of this RoboticScope. I can move my head like I want to, and to find a very comfortable position in sitting in front of the CEST and in front of the patient, and doing surgery in a very comfortable stability. And so to activate the microscope, I have to push a button, and then I have, after adjusting the head-mounted display to my head, I have a perfect view on the patient and on the mastoid. And we prepared a mastoidectomy, and now we want to do the last steps for opening the middle ear with the posterior tympanotomy to have a good view on the round window. And what we will do is the insertion of the electrode probe, and I will start with the drilling now.
So as you can see, Professor Bohr is looking on a quite lateral angle into the mastoid, but the camera still is staying straight, to ensure that he has enough space between him and the robotic scope, and to make sure that he can see from this angulation. What we do is that we are fading in the user interface, so that the user is always having the feedback what the system does. And this is also true for the assistant, because the assistant also knows what the main surgeon is doing. So Lucas can see live what Professor Bohr is adjusting with the robotic scope. So he's also having a clue what's going on with this medical equipment.
So here we're coming near to the facial nerve area. And the quarter facial angle here. here now you can see the angle between the facial nerve down here and the chorda tympani up there. And this is the part where I have to open the middle ear. So a little bit solution, please, here. A little bit rinsing. Okay, thank you very much. And now I change the burr onto a smaller drill. Thank you very much for the help.
Sure. Okay, here's drill.
Perfect.
How does it feel? How is the depth feeling? Do you have a good orientation inside the mastoid, or is it different from?
No, it's a perfect view, and I have a perfect feeling of the 3 dimensions of the mastoid bone.
Actually, we're having with our model a slightly different 3D angulation, and that's why the depth is a bit higher, usually compared to optical microscopes, and should give a more intense feeling with this type of system.
A little bit more. Okay, so we have a little bit dust in here, and we have now to try to get that out. And this is a little bit sticky on this model here. The burr dust is something else than the bone meal, what we normally have, and we have to now rinse the middle ear, and I do it by myself because I think we don't get out the stuff here otherwise. Now I focus more on the round window. Make it a perfect view. So das ist jetzt noch ein bisschen nachstellen. Muss noch mal ein bisschen zu schärfen. Und nehmen wir jetzt mal eine Nadel, um das da rauszukriegen. Es ist nach wie vor so, dass so it's still that we have the burr meal here on this area where we want to look to. Leider im Moment das Bild nicht ganz scharf. Ich weiß nicht, wie es auf dem Monitor ist, aber kann ich nochmal das Testbild haben, bitte? Das Testbild ist eigentlich perfekt. now.
I will also demonstrate this is the same working distance which is many times used in analog type of technologies. Of course, the RoboticScope can be the same.
Now it's a clearer view on the round window. We now see the edge of the round window. I have to drill a little bit more to get closer and to have a bigger overview, a better overview to this area. I have to remove a little bit more of the bone here. Now I change the angle to optimize the view.
The beautiful thing is that you are far away from the camera itself and still have this flat elevation. Lucas, how do you feel as an assistant on the opposite side?
Perfectly comfortable.
No fear from the robot?
Not at all, no. I still got my view peripherically here, but I got lots of space here.
So here we have the Phacon, and this is the edge of the round window, and I hope that you all can see now here this kind of shadow which is the round window. Which are open now. Okay, now we have a good view on the round window, which is here. I can show you with the needle, and you see that I still can sit in a very optimal position, and here you have now the round window, and here the quarter and facial nerve angle, and so it's easy to visualize this region of interest in my surgical field. And to get a better overview on the surgical field, I can defocus a little bit, and this is very easy as well. So now I have the perfect view here on the window, and so it's easy now to take the electrode and bring it into the surgical field.
Now you look underneath, right? You look on the electrode, how to touch the implant.
Yes.
And at the same time you have the view to the surgical area, right?
Yes, that's right. So it's easy to handle. And now the part is going on here to get this electrode nicely and straight into cochlea, and this is a little bit quick maybe, but this is how to get it into. Okay, so you have, I hope so, you have a perfect view like me on my display, and very precise, very sharp, and I'm in a very comfortable position, can move my head and don't lose the picture of the surgical field.
What can you also show us a bit of the inside of this anatomy, like zooming in and orbiting a bit around?
Okay, I think it's
the landmark.
Yeah, I think it's easier to take now the electrode out again, and then I can show you a little bit the anatomy. So when we started the surgery, I can start with the maximum of the surgical field here on the mastoid bone, and I start by touching the landmarks here, the crista temporalis, and here the bony part of the outer ear canal, and then I can see the labyrinth, and I'm drilling into the antrum, and I search for the incus.
Can you just orbit a bit, because the
Of
audience
course,
can see
I'm
just
sorry.
the left eye. You have a perfect 3D view, you know, and they just one eye over here. So thank you very much.
Now we turn. We see the skull base here on the left side. And so we see here the incus, and so this is the labyrinth, and then I opened here the middle ear part, and you can see the facial nerve here coming from here to there, and the quadra tympani being up there. Yeah, and what you else can see is here the stapes. This is the stapes. And it's very easy to get into the surgical field with a maximum of zooming into, and now I sharpen the build, the picture. Now you have a perfect view. So this is the tens of the stapes, the green here. This is the facial nerve, and this is the stapes. So perfect view, and I can change the angulation and visualize the round window as well as all the other structures of my middle ear and the mastoid bone.
So actually you're changing the perspective very fast to get a good orientation. Is this an advantage for this type of procedure?
It is a big point. So if you have to search for landmarks, it's very good to get an overview, and it's on the other hand perfect to visualize landmarks, to identify landmarks, and so I think it's a very big advantage. Another big advantage is that I don't have to take my hands out of the surgical field to move the scope. So this is perfect because I can still have my suction inside, I can still have my needle inside, and can manipulate by moving the picture, moving the angle of the view on the surgical field. Okay.
Okay.
So, are there any questions so far?
Not at the moment. Maybe we can show the application with middle ear prosthesis.
Okay, so we change our point of view. So now here you can see the quadra, and it's a very nice view now because you can see here the facial nerve underneath the bone coming up here and going here into the middle ear part, and as well you can see here the quarter tympani coming up and here going further onto the middle ear and touching the incus. And also here is something prepared a little bit. So we opened the middle ear by lifting the eardrum a little bit. You can see this here. This is the eardrum, this is the quarter tympani, this is the incus, and down here there's the stapes. So we drilled out the angle between the stapes and the incus. And what we can do now is taking the prosthesis, and what is a big advantage is that we can save some microscope positions and now move the microscope position onto the prosthesis. Sorry. Number one. Let's see.
Right. Usually we take a picture when the position was done, just to make sure that you don't have to remember which positions you have saved in, what is number 1, number 2, number 3, and therefore we are taking a picture, an image, before while saving the position from the robotic position. Now what you can see is a passive middle-ear prosthesis, a titanium prosthesis, thankfully provided by Uwe Steinhardt from Medel. And yeah, this is one of the latest generations, which is now on the market. Nice reddish box.
Yeah, perfect view, and comfortable for me to turn my head, to turn my body a little bit, to get onto the best possible position to take out this little prosthesis here.
It can be taken out the prosthesis, or it can be a place where you prepare cartilage or fascia pericondium, right?
Yeah.
And then you straight can go back to the position you have previously chosen. Number 2. You can see here the image was captured while the position got saved, and so that the prosthesis can safely stay in the hand of the surgeon. And for maneuvering, it's not essential to take away the prosthesis. Since when you have the prosthesis once in your hand, you don't want to lose it. And even though the position is not 100% right, because the patient moved or you changed the table, you can just go from there and reorientate yourself and correct the position. And then you're safe with this highly sophisticated prosthesis in your hand.
So we don't have a small suction here, so this is but no problem. And I will try now to fix this poor prosthesis onto the stapes head.
Nice position. The beautiful thing is that we can do this with the digital technology, because of course saving a position of the robot and certain magnification is not an issue at all for a digital system. and it can help to optimize the workflow of the surgery. And that's why we constantly are thinking about how to improve processes, and this is possible with the same hardware, but with new knowledge provided by the users. So with every user which is using the RoboticScope, we are learning, and we can implement this into the innovation. Because at the end of the day, what matters is to have the processes in a way that the surgical processes are optimized for the patient, of course, also for the surgeon.
So what I did before, I tried to fix the prosthesis on the staples once before, and it's very hard with this floppy eardrum here, because the eardrum always pushes my prosthesis here into a wrong position. So I'm sorry for the delay now.
It's not 100% a real case, this is done for real patients and not for artificial bones, but it perfectly demonstrates, how you can handle this type of procedures, when having implant materials or transplant material and to prepare it on the side table, and how fast you can switch between those two positions and what the advantages.
And I think you can see that I have a perfect view on my surgical field, and this is the most important thing today, to demonstrate what the microscope is able to do and not what I am able to do, and I'm happy for that. But this is not the point today.
How is the resolution compared to the analog technology? Is it sufficient with the digital one, or is it different? How does it compare?
I think it's very comparable for the moment, because the picture I have is very natural, the colors are very natural, and so it's a very comfortable, normal feeling for me, being used to use a standard microscope, and I don't feel any differences, but with the possibility of digital image processing, I think we can develop some very big advantages for the surgeon by visualizing anatomical structures, and or to point out anatomical structures, what we are for the moment are not doing. So I think there is very much innovation possible, and I think we will get many things in future to make the life of surgeons easier with this kind of digital imaging.
So now you're demonstrating a tympanoplasty. Do you think this is also applicable for staple surgery?
Of course it is. So because it's no different. The visualization is perfect, and I have a perfect view and on all the structures. So I don't think there are any limits.
So you believe that for the majority of ENT procedures, or let's say autologic procedures, you can use the RoboticScope for the visualization?
Yeah, I'm very much convinced about this. Yeah, I believe on that. Yeah, so here, this would be the end of the procedure, pushing the prosthesis a little bit down here, fixated on the stapes, and getting back the eardrum.
Excellent. So it was an excellent procedures, 2 implants in one day, and also we have seen the cochlear implant with all the landmarks, the movability of the RoboticScope. What we also observed is when you use the RoboticScope, the camera head came never close to you. It looked quite easy from the outside. How did you feel to use the RoboticScope with the ArcView?
So I'm very happy about this development. The ArcView makes the conflict between the microscope and the surgeon much easier, so we don't have any conflict anymore. In former times, so sometimes the head of the RoboticScope got too much into the surgical field, and I had to change my body position to don't get in conflict with the microscope. Now I don't feel this conflict anymore, and so it's very easy to sit in front of the patient. And so if maybe I have some procedures completely different, it's like being very much easy and movable with my body, and can find very easy the best and most comfortable position for my surgical procedure.
Thank you very much for that for the great demonstration. Now I would say when we do the question and answer session,
Okay.
and therefore we'll just make some slide changes to the setup. And now we want to answer the questions from the audience.
So,
We've seen some questions. Some of the points we already answered or discussed during the procedure. I think was quite good.
yeah, there are lots of questions. Unfortunately, we didn't get any questions so far to the chat. So please, if you have anything, just type it in. I have my computer with me, so I can read it, and then we can discuss the team with Professor Bohr on the live show. Otherwise, yeah, maybe you already said something about that you don't see any limitations on the in the surgeries or the usability of RoboticScope there. But which surgical procedures would you think would be the best ones for RoboticScope? Where is it? Where does it fit the best, in your opinion?
Okay, this is not an easy question, I have to say. So if you don't see any limits with the microscope, there are no limits for the best procedure. And I think the procedure is the best one is that on which you are feeling the most comfortable surgical doing. But so I think every surgical procedure which has to be very precise, which has to be done with a microscope, can be done with this microscope, with the RoboticScope. And and if you don't have any limitations, there are no limits.
Yeah, that's true. But what about which characteristics make, in your opinion, RoboticScope special? For example, when we think about like autologic surgeries or something, why is it special, or what makes it different to normal surgical?
So different is the surgeon's position in front of the patient. So we are used to be behind a microscope and don't move the head anymore. So for the rest of the surgical procedure, except you have to twist the angle of the view on the surgical field. So, and now with the RoboticScope, it is easier because you can do little movements with the head without losing the point of view. And if you have long procedures, long surgical procedures, I think this might be or is an advantage.
Yeah, I think surely, because then you're not staying in static position all the time, and your muscles can relax when you're just sitting comfortable.
Yeah, and I think this is one of the problems of most of the ear surgeons around the world, that when they have done 15 or 20 years of ear surgery, they're getting problems.
Yeah, I can imagine that. What about, I think quite often the question is with RoboticScope, because it's so different from the normal traditional microscopes, quite many surgeons, they're worried about the hand-eye coordination. What do you think about, like, is it good? Do you still have a good hand-eye coordination when you're operating?
I didn't feel any difference to a normal scope. Yeah. So this is very comparable.
Like even with the ArcView, there's no difference for you, because I mean the camera is sitting straight, you know, and then there's a 45-degree angle of with a mirror, you know, and But it looks like that the brain can adapt exactly what you see and what your hands are doing, right? So so it looks like that the brain is more flexible with that than we ever think. Yeah.
I think what counts is the picture, and not the angle how the picture is created.
Yeah.
So, and we are used to do surgical procedures with angled scopes from the FES surgery, the parallel sinus system. So, and I think this is something you're getting used to.
What do you think? What's the value for younger surgeons of these technologies? I mean, you are an expert, and you did so many sort of orthodontic procedures. For you, you're at the top level. But what's happening with younger surgeons who are just now starting with ear surgeries? Do you think that they can adapt to this technology easy, or do you think it's difficult?
I wouldn't see any big difference in this. What is an advantage is that you can take an assistant onto the surgical field by the second display. So the second head-mounted display allows you to take an assistant into the surgical field and give him the complete same view like you have on the surgical field, and you can explain him. When we are teaching young colleagues, they are sitting next to us, but they are looking on a screen, on a 2D screen.
Yeah.
And now they have the possibility to get into the deeps of the surgical field by having the second hand-mounted display, and so now they are even in the position to help you a little bit, or to do some parts of the procedure.
Yeah. It means like also for teaching institutions like the university, it's a benefit, and getting them closer to the surgical area using the same 3D image like you see as a surgeon.
Yeah,
right?
that's right.
Yeah. Which also means that once in a while you can, if somebody is doing it, doing the procedure, and you are the assistant and just watching, observing what he does, right? Some small steps you can even do next to him, right?
Yeah. And this is something else. Of course, you have microscopes with an additional tube and have the same effect. But when you have an additional tube, the assistant cannot sit next to you. Yeah. And so you have more degrees of freedom.
Yeah. Absolutely. And that's why we are trying to make sure that because we have the technology, we can do it, and that's why we do it, because we can do it and it's a benefit. This is very simple. We are also a company which is observing very quick, and due to the design of the RoboticScope, the digital base of the system, we can quicker react to input we get from the field. We don't need years, to improve the angulation of the optical pathway. We just build a sophisticated mirror, make a lot of software, make a great usability out of it, and bring it as fast as possible to the market to make sure that you can use it. Because every surgery counts, and every surgery which is done without great innovation is a surgery which was done without innovation. And we believe if we bring it faster to the market and make sure that it's available, we are helping to get surgeries better done, for you, because we are making just the tools for you to make sure that you perform.
Yeah. So I'm really impressed by the speed you have, how quick you are in developing things, because it's half a year ago when we had the first idea to implement such kind of an ARC system, and now we are doing surgery with that. I'm impressed, really.
Thank you very much. It's also thank you to the R&D department who is building up processes which are so lean, that these things are possible, and of course, RoboticScope, like every innovation, every new category will never end. It's living from the users, and from the input from the users, and it's creating a great community, with RoboticScope users where we can learn from each other. That's also the reason why BHS Technologies is, of course, serving the ENT field, but we can also learn from plastic surgery, from spine, and also from neurosurgery, because they all operate on human beings, and you know, there's a connection always between those parts somehow, and we also want to make sure that, you know, the things which works great is also implemented into this development. Thank you very much.
Thank you very much.
Thank you very much for the audience for listening and watching. You know, I hope you enjoyed this demonstration, this show, and yeah, I'm looking forward for the next users to come on board and make sure that they can get the benefit from the RoboticScope.
Okay.
Thank you.
Thank you.